Hi, my name is Imran, and for my Vehicles Engineering 2 term project, I've been working on building a gas turbine engine based around a truck turbocharger. As a refresher, in my midterm presentation, I went over the basic principles of a gas turbine engine, namely the Brayton cycle, which is the thermodynamic cycle these engines use to operate. I also discussed the various components of the engine I would have to build, as well as showcase some of the work I had done to date, which included completing the oil, fuel, and spark systems, as well as having procured the turbocharger and created a CAD model for the combustion chamber and the frame. Since then, the parts which were ordered for the frame had arrived, so I was able to put that together. Additionally, a contact of mine was able to laser cut my parts based on the drawings I'd created in my CAD model. Once I had all of these raw materials cut into the right shapes, my next task was to do any additional of the formwork by hand. This included drilling holes in the combustion liner, coping the pipes for the combustion chamber, and bending some of the sheet metal to make a 90-degree circle to square to rectangle transition piece. Once all these parts were ready to assemble, I worked with a friend of mine to weld them together. The design allows for the easy removal of the end cap containing the spark plug and fuel injector for easy service, as well as the combustion chamber liner should it need to be modified or swapped out. Once the combustion chamber was welded together, it was installed into the frame, followed by the turbocharger and the previously mentioned auxiliary systems. The spark and oil systems were both mounted onto a control panel attached to the side of the frame for easy visibility and accessibility. Finally, the project was done and it was ready to be run. So after a bit of an issue with the propane line I initially procured shutting off flow and the oil system not wanting to hold together, I was able to successfully start, run, idle, and throttle the engine. I'll now demonstrate the startup procedure of the engine. First, the propane tank must be connected to the propane line. Second, a fully charged drill battery is plugged in and the nominal voltage is verified on the low voltage cutoff module. Once a satisfactory voltage is displayed, the oil controller may be set to a low input to begin circulating oil through the bearing of the turbocharger. Ideally, this is around 10 psi, so the turbocharger spins fairly freely. Now, a leaf blower is placed in the inlet of the turbocharger and set to full throttle to begin moving air through the system. The spark is then depressed and held while the propane is opened roughly 1/2 turn. The engine will produce a loud and forceful pop noise, signaling that the combustion has begun. The sparker may now be released. With the leaf blower still held on, the propane flow is slowly increased into the engine until it no longer sounds like it is accelerating, meaning that it is now self-sustaining. The leaf blower may now be removed and the oil pressure increased as the engine has successfully been started. The throttle of the engine can now be controlled by opening or closing the valve on the propane tank. While we watch some of this footage of the jet engine running, I'd just like to go over a few next steps. These include potentially switching the engine over from running on propane to running on diesel fuel. Another option would be to add an afterburner on the back of the engine. This would take extra fuel and dump it into the exhaust stream to recombust any of the air which was not initially combusted the first time and produce extra thrust. In order to shut off the engine, propane must first be cut before the leaf blower is once again placed over the intake of the engine and it is spun to remove stored heat. The leaf blower should be run for several minutes in order to cool the engine and the bearing down, and the oil system should run for several more minutes after that to remove excess heat from the turbocharger's core. With that, thank you for listening to my presentation, and I hope you've enjoyed it.